Bismillahirrahmanirrahim and Assalamualaikum. We are from Group Marconi for ESC301 Group Project. Our project is modeling of instrument and landing system using Arduino. So this is our group member. We have Lizzie Wei, Hiba, me, Takif, Tengku Nakyudin, Habib Alwi and Nurul Nabila. For introduction, our concept of project is to mock the ILS concept and use it on the Arduino powered car. There are two main parts for navigation system, which is pathway guidance and distance indicator. Our objective is first one to develop a navigation system based on the concept of ILS, and second one is to verify the performance of the ILS itself.
Hi, my name is Nurul Nahmiah Azman. I will present about the circuit connection. So for our circuit connection, we can divide with the three circuit connection, which it can make our easier to understand. So first, we have the circuit connection of Arduino power car. For the slide in the middle, we can see how we set up our component and the hardware. For this circuit, we have the two main component important, which is the R298N motor driver module pin configuration, which it is a controller that uses an H bridge to easily control the direct and speed of up to 2 DC motors. And next, we have the HC06 Bluetooth module pin configuration, which it used for control the robot car. Secondly, we have a circuit connection of frequency detection system. For this circuit, we also have two most important component, which is a sound detection sensor pin configuration that function to detect the frequency. And next, we have the LCD display pin configuration, which it will be display the number of frequency. The third, we have the circuit connection of our IR distance indicator, which we have the IR LED, we have the IR photodiode, which it will generate a potential difference or charge its electrical resistance, and we have the transistor to switch the circuit. Thank you.
Hi and Assalamualaikum. I will explain about the system setup. So this is our Arduino car setup that connected to the Bluetooth module, so we can control using our smartphone. And this is the sound detection sensor, which acts as the localizer receiver. The sensor is mounted at the front of the car for better sound detection. Then the IR photodiode is mounted at the bottom of the car's platform, so it is aligned with the IR transmission LED for better IR transmission. For the pathway guidance system setup, we use two buzzers to mimic the function of the localizer to generate the sound wave with different frequency and located separately at the end of the runway. The frequency of the buzzer can be varied by applying different resistance in the circuit. In our project, we use 2000 ohm resistor to the buzzer for producing 650 Hz sound wave and 440 ohm resistor to the buzzer to producing 850 sound wave.
I'll be talking about the working principle. The first one being the Arduino power car. We uses a motor controlled by L298N DC motor driver module. We combine two techniques, which is a PWM and a H bridge, to control the speed and rotation direction respectively for a DC motor. PWM meaning is a pulse width modulation. It is a technique to control the rotation speed of motor by varying its input voltage. The average voltage is proportional to the width of the pulse, known as duty cycle. So the higher the duty cycle, the greater the average voltage being applied to the DC motor, which gives higher speed, as shown in the figure below. A HB circuit is a 4 switch connected to the motor and form a H-like arrangement. So the motor starts to spin when both input signals are different, such as one input is high and another one is low. The motor will stop spinning when either both are high or low. So for sound detection system, we use a fast Fourier transform, which is an algorithm used in our project to break down the signal we get from the sound detection sensor to its frequency. So the transformation is illustrated in the figure below, where it's used to transform the signal gain from time domain to frequency domain, and this is the equation. And for IR distance indication system, it is a simple IR communication circuit The IR transmitter, it transmits a digital logical 1 data continuous at the location of 10 cm away from the runway end. So with the data transmitted is in the form of infrared light, and when the on data is then collected by the IR photodiode in the Arduino car, which is 10 cm away from the runway end. So a signal is provided to the base pin, which is BC547 NPN. The transistor is activated, allowing current to flow through the collector pin and reach the LED. So thus the circuit is complete and LED lights up.
Good morning, Dr. Faisal and Dr. Aifa. My name is Li Zhiwei, and I'm going to present the program for our system. First of all, let me show you the flowchart of our program. Basically, our program can be divided into two parts, which are sound detection and movement control. Since we need them to work simultaneously, so we add a timer interrupt function in our program. Let's move on to our Arduino codes. At the beginning, we have imported three libraries here. The first one is the Arduino fast Fourier transform library. It is used to transform the sound wave signal into each dominant frequency. The next one is the library for LCD display, and the last one is for timer interrupt. Then we define all the variables that need to be used in our main code, like sample size, sampling period, and label the input pin for our motor driver. For the setup, we open the LCD port for serial communication, so the things in the serial monitor can be displayed on the LCD. We also specify the serial communication baud rate to 9600. Then we continue with the sound detection program first. First of all, we calculate the period of the sample. In the loop, we use for loop to record every input signal from analog pin 0. Then we perform the fast Fourier transform on each sample here and call out the highest frequency among the dominant frequencies. The highest frequency is then displayed on the LCD. So this is the message that we want to display, and we only use the first row of LCD to display it. Then we use if statement to display the respective instruction like turn left or turn right according to the detected frequency. And I add the delay command for it to refresh every 1 second. So this is our program for sound detection system. Let's move on to the next part, which is Arduino car movement control. Firstly, we define each movement as a function. Inside the function, the code is used to send the signal to the motor driver. After defining the function for each movement, we define a new function here. The code means that if the serial monitor receives W from the serial command, it will run this forward function, and this is the command for other movement. Since we need two parts of individual program work simultaneously, so we initialize the timer interrupt in the setup and set the time interval as 0.1 second. Then we insert the movement function that we defined just now as an interrupt program. With this setting, the Arduino will check the movement function every 0.1 second, so it won't be affected by the system delay in the sound detection program. That's all for my presentation. Let me pass to my group mate. Thank you.
Hi, I am Habib Alwi. Okay, so how do we control and measure our system? Okay, for controlling the car, we use the Arduino Bluetooth controller by sending the serial commands via Bluetooth module at 9600 baud rates. The controller button is set up as W, A, S, D, and O. Like an example, when button triangle representing W is pressed, the car will move forward, and when the button is released, it will stop immediately. For the sound detection system, the detected sound frequency will be displayed on the LCD screen along with the direction it has to move. When detecting an 850 Hz frequency, the screen will show us to turn right. When detecting a 650 Hz frequency, the screen will show us to turn left. And when the car detecting an in-between frequency, means it is in the middle of the runway, the screen will show us to move forward instead. As representing the beacon marker, when the car reached the IR transmitter LED, which is before reaching the end of the runway, the LED on the Arduino car will light up.